Welcome. We've got day 2 of our final exam review unit. So let's go ahead and take a look. Our goal for today, given a word problem, you will be able to draw a picture, identify key information in the problem, and then set up an equation to solve. All right, so let's jump right into it. So our very first problem here, express the perimeter and the area of the rectangle math algebraically in simplest form. So the keywords we have here are perimeter, area, and the idea that this shape is indeed a rectangle. So let's just review. If it's a rectangle, that means opposite sides are going to be equal. So if this side here is x minus 5, the opposite side is x minus 5. Same thing, 3x plus 2, that means the top is 3x plus 2. Now they want us to find the perimeter and the area. All right, so perimeter in this problem, we have to remember perimeter is add all sides. All right, so let's go ahead and for the perimeter here, we're going to add up all of our sides. 3x plus 2 plus x minus 5 plus 3x plus 2 plus x minus 5. All right, now we're going to go ahead, add up all your x's, add up all your constants, and our perimeter ends up being 8x minus 6. Next, for area. Now, the formula for area of a rectangle, area equals length times width. Now, if we look at our length and our width here, they are binomials. Now, binomials are quantities, and quantities go into parentheses. So we're going to put parentheses around our length and our width. So area is going to be 3x plus 2 times x minus 5. Now it's your choice. You can either go off to the side and use the multiplication box, or you can use long distribution. So 3x times x, 3x squared. 3x times negative 5, negative 15x. Okay, plus 2x minus 10. Now, when we add all of these, or when we combine our like terms, we're going to end up with 3x squared minus 13x minus 10. And we have our final answer for perimeter and area. Okay, next up, we're going to take a look again at the area of a rectangle. Well, this time it's a little bit different. So 2 rectangles here are shown. Now, we want to express the area of the shaded region. So here's what I want you to do. Imagine this is a big sheet of colored paper. Okay, and what we're going to do is we're going to cut the rectangle out of the middle. Okay, so if we're cutting something away, that means we're going to be subtracting it. So the area of the shaded equals the area of the big minus the area of the small. Okay, so let's go ahead and let's complete the area of the big and the area of the small. So once again, I'm going to put all of my quantities into parentheses. So area of the big is going to be 2y plus 6 and 2y minus 3 minus the area of the small. Well, that's 2y times y. Okay, now once again, I'm going to go ahead and use my long distribution, or you can go off to the side, use your multiplication box. And the area of the big, your final answer becomes 4y squared plus 6y minus 18. Minus, now when I multiply these over here together, my area of the small is 2y squared. Now, to get the area of the shaded, I'm going to subtract, so we combine our like terms here. So the y squared, so all together we have 2y squared plus 6y minus 18. And we've got it. All right, now let's take a look at a few problems where there's no pictures for us. So we have to read very carefully, determine what we're trying to do. If we can draw a picture, we will, and if not, we'll just go right into setting up an equation to solve. So number 3. Rachel and Sabine belong to different local gyms. Rachel pays $35 per month and a one-time registration fee of $15. Sabine pays only $25 per month, but had to pay $75 registration fee. After how many months will Rachel and Sabine have spent the same amount on their gym memberships? Okay, so number 1, there's no shapes, so we don't have to draw any pictures. All right, now let's review the question here. So what's happening in this problem? Well, we have 2 people, Rachel and Sabine. Okay, we're talking about their gym memberships. There's a lot of very important information here. But what do they want us to do with that information? Well, let's go to the last paragraph, the last sentence. After how many months will Rachel and Sabine have spent? The same amount. So if they want us to know the same amount, that means they want to know when will they be equal. And that's the main idea of this problem. We want to know, when is Rachel going to be equal to Sabine? Okay, now that we have established what we have to do with this problem, now we're going to go back and reread and find our important information to write these equations. So Rachel pays $35 per month and a one-time registration fee of $15. So $35 per month and a one-time fee of $15. So $35 per month plus a one-time fee of $15. Sabine pays $25 per month and $75 registration fee. So $25 per month plus $75 registration fee. That happens at the very beginning and it only happens once. Now we're going to go ahead and solve for x. When you do that, you get x equals 6, which means after 6 months, they will be the same. All right, let's go ahead, flip to the back. We have 3 more problems to try. So here we go. Number 36. A contractor has 48 meters of fencing that he is going to use as the perimeter of a rectangular garden. The length of the side of the garden is represented by x. The area of the garden is 108 square meters. Determine algebraically the dimensions of the garden. We're going to cross off this word algebraically because today I'm going to show you a new way to solve this. So we just want to find the dimensions. So the main idea here in this problem is we want to find the dimensions. Now the dimensions are all the sides. Okay, so we want to find what are all of the sides. So let's go back and first let's decide, well, what shape are we using? We're using a rectangle. So I'm going to draw my rectangle. And it said one of the sides is x. Now we need to think, did it tell us what the other side is? No, it didn't tell us any relationship to find that other side. So let's go back and let's find the other important information that it did give us. A contractor has 48 meters of fencing that he is going to use as the perimeter. Okay, so 48 and perimeter. So that's important. 48 and perimeter, that's our first piece of information. The area of the garden is 108 square meters. Ooh, so area is 108. So I'm going to go ahead, I'm going to write these two things down. So area is 108 and perimeter equals 48. So we have to find a length and a width that will multiply to 108 and all 4 sides will add to 48. So remember, area is length times width. And over here, we're going to add 4 sides. So what we're going to do today is we're going to use a method of guess and check. So we're just going to guess some different numbers and we're going to see if we can find numbers that will work. So let's try to find 2 numbers that multiply to 108. 108 divided by 2. Ooh, 54. So if I did 2 times 54, that would be equal to 108. So I could have a side of 2 and 54. Let's see if perimeter works. So 2, 54. Let's see if it'll work. So 2 plus 54 plus 2 plus 54. So 2 plus 54 plus 2 plus 54, we get 112. So that is definitely not equal to 48. So these will not work. So we have to try another number. So I'm going to go 108 divided by 4, 27. So 4 times 27 equals 108. So let's try the perimeter. 4 plus 27 plus 4 plus 27, and we get 62, which is not equal to 48. Can't use it. So let's try 108 divided by 5. Doesn't work. 108 divided by 6. Oh, it works. So 6 times 18. Now let's add them together. 6 plus 18 plus 6 plus 18, and we get 48, which is exactly what we wanted. So that means our dimensions are going to be 6 meters, 8 meters, 18 meters, 6 meters, and 18 meters. And we've solved the problem. All right, let's try another one. So let's take a look now at question 4. Amherst State Park is planning on undergoing renovations to its garden. The garden is a square shape with side measures of 10 meters. The new garden will also be square-shaped, but it will have an increased area of 25%. Find the area of the new square garden. So if we take a look at this problem, we're trying to find the area of the new garden. Okay, so now we need to think area equals length times width. So let's see if we can figure out what the sides are. Amherst State Park is undergoing renovations. The garden is a square shape with side of 10 meters. So the original is 10 and 10, which means the area of this small garden, 10 times 10 is 100. Okay, now for the bigger garden, the new garden will be square shaped, but will have an increased area of 25%. So we do not know the sides. It does not tell us the sides of this garden, but it does tell us that it's going to have an increased area. So that means the new area equals the small area plus 25% of the small garden, or the small area. So let's go ahead. So our new area equals the small area, which we found to be 100, plus 25%, so 0.25 times the small area, which is 100. So when we multiply all that together, 100 plus 0.25 times 100, we get 125 would be our new area. And that would be meters squared. And we've got it. All right, one last problem for today. So let's take a look now at number 5. New Clareton Garden is undergoing renovations to its gardens. Oh, just like the one above. One garden that was originally a square is being adjusted so that one side is doubled in length while the other side is decreased by 3 meters. Draw a picture with dimensions to represent this situation. Okay, so one garden that was originally a square. So here's a square. Now it doesn't tell us sides, so I'm going to put X for these. It's being adjusted, so it's changing, so that way the length is doubled. So we're going to double the length. So from X, this becomes 2X. While the other side is decreased by 3, so we're going to make this one smaller by 3. So X minus 3. Okay, so now we just drew a picture with our dimensions. Part B, the new rectangular garden will have an area that is 25% more than the original square garden. Write an equation that could be used to determine the length of a side of the original square garden. Well, let's go back here. The new garden will have an area that's 25% more than the original. Well, doesn't that sound very similar to this up here? So the new area equals small area plus 25% of the small area. So let's come down here and let's try that. So we're going to go area of the new equals area of the small plus 25% of the small area. But now here, this sentence here, write an equation that could be used to determine the length of one side of the original square. That means they want everything in terms of X. So we're going to find the area of both of these and plug it in. So our area here is X squared. Our area here, 2X times X, is 2X squared minus 6X. So here we go. Our new area is 2X squared minus 6X equals area of the small is X squared plus 25%, 0.25x squared. And now we've created our equation. All right, nice job, everybody.